Okay, so first let's look at the term algorithms. We use this term a lot. So my field is machine learning. When we talk about machine learning, we will discuss algorithms. We will say that a neural network is trained by a optimization algorithm, like ADAM, like statistical gradient descent, and so on, backpropagation, and so on. So all these algorithms, they all share one kind of common place. So I think it's the common place that define the concepts of algorithms. Okay, so technically, an algorithm is a computational procedure, okay, that takes some value as inputs and produces some value as outputs. Okay, it is some sequential procedures with inputs. Given inputs, it will give some outputs. Okay, and it is used as a tool to solve a computational problem. Okay, so often the name of an algorithm is defined by the name of the problem. Okay, we'll see a lot of that examples later on throughout this whole class. So the names of, I would say, the graph algorithms, right? When we talk about graph algorithms, it is defined by the realm of the problem, right? We're solving the graph problems, and that's why we will have graph algorithms. Okay, and the problem defines a input to outputs mapping relationship. So input and output is also very important concept throughout this whole class. Okay, and as I said in the first sentence, the algorithm describes a specific computational procedure to achieve this input to output mapping relationship. So, for example, we'll look at a sorting problem as a very beginning, as a very first example. So what is a sorting problem? We all know how to sort, say, play cards, right? When we have a handful of cards, we want to sort them in such an order that's it's easier to play. So you can think of sorting problem as a procedure that takes the inputs, right? So a sorting problem takes the inputs as a sequence of numbers. If we have n numbers from A1 to AN, that sequence is our inputs. Okay, and the output is a permutation. We simply want to reorder that input sequence, and we get a new sequence from A1 prime to AN prime. It is the permutation of the original input sequence, but we want the output to satisfy the condition that the first element is the smallest. Okay, it is smaller than or equal to the second, and smaller than or equal to the third, blah, 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 until the last one. We want it to be such an order, okay? So that is how we officially or technically define the problem of sorting problem, okay? So by defining the sorting problem, we also define the algorithm, right? We'll basically define the procedure, we're basically saying that the procedure that takes the inputs and gives such an output is the sorting algorithms, okay? So in this particular example, we can have several different algorithms that takes the inputs 31, 41, 59 to 58 and generate the outputs in ascending order, okay? So this is a very simple example of what a computational problem could be and what the algorithms are doing. Okay, so speaking of algorithms, we care about the correctness. Okay, because we are defining algorithms based on the computational problems, and if the problem can be solved, we can verify whether a solution is correct or not. Okay, so we say that an algorithm is correct if for every input instance it will stop or it will halt with the correct output. Okay. And we say that a correct algorithm solves a computational problem. Okay. So the solve and the correct concepts, they're closely related to each other. Okay. We only want, so typically speaking, we want the algorithm to be correct. Okay. But that is not necessarily for all the case. So an incorrect algorithm, it could pause with an incorrect output, okay? Or it may not stop at all. But such an algorithm is sometimes, in some rare cases, it could be useful, okay? As long as the error rate is controlled, or it is not deviate too much from the correct output, okay? So the main reason is that an incorrect algorithm, it may not give the right answer, but it could be due to the fact that the right answer is simply too hard, too difficult to achieve, or basically impossible to achieve. Then we want some algorithm to approximate the correct answer, okay? Even though it is incorrect, but we will tolerate that error, okay? But primarily speaking, especially in this course, the correct algorithms is our primary concern here, okay? We want algorithms that gives the correct output, given the inputs. It always correct outputs, okay? So next, we're gonna look at what kind of problems can be solved by typical algorithms.